Hello everyone! In this video, I'm going to be talking about the absolute value inequalities and how to solve for them, as well as give you an introduction to interval notation. This is going to include information from the previous video, so if you guys haven't watched the previous video, there's going to be a link in the description that you guys can click on to watch that first. Previously, you might have learned about inequalities and how if you have a less than or equal to or greater than or equal to, if you want to graph it, the circle is usually filled in. In something called interval notation, which you will see in a minute, the greater than or equal to and less than or equal to are represented by brackets. For the inequalities that do not have the equal sign on the bottom, like less than or the greater than symbol, those are usually open circle when graphed. And to represent it in interval notation, we use parentheses. So let's go ahead and actually graph the notation where A is less than or equal to X, less than or equal to B. What this means is that X is just between A and B. So let's actually go ahead and either fill in or leave our circle blank. Since we have the less than or equal to symbol, since it's included, we have to close our circle and fill it in. For B, it is the same thing. There is also a less than or equal to symbol, so we are filling in our circles. Since our X is in between A and B, that actually means that we're shading in this middle section. So this is our graph for the interval where X is between A and B. Now let's write this in interval notation. Interval notation means that we're going to consider each side, and we read it from left to right. So the first thing that we encounter if we're reading this graph from left to right is A. So for A, is A being included or not included? That is the question. And since it is being included, we're going to write this in a bracket form. So we're going to have a bracket around A, and the graph goes up until B, and B is also included, so we need a bracket around that. Now let's move on to the second case. For this, we have A less than X less than B. So this is similar to the previous one. But now, since it is less than and not being included because it doesn't have the equal sign underneath, they are open circles. And X, again, is in between these 2 points. So now if we want to write this in interval notation, we start from reading the graph from left to right again. The first thing we encounter, again, is A. But since it's not being included, we write it with parentheses. So it goes from A all the way up to B, and it is, again, not being included. We can also have something that has half and half. So if A is less than or equal to X but less than B, that means that our A is, in this case, is being included, but our B is not included. And again, this is X is in between A and B, so that is this middle section here. And our interval notation would include A, so it has a bracket, and it goes up until B. But B is not being included, so it has a parentheses. For this last one here, let's graph our A. So this one says that X is less than A. Since it's less than, it has to be anything before A. So that's anything to the left of it. The next part says that X is greater than or equal to B. So since it's equal to, we have to fill in our circle. And since it's greater than, it's anything to the right of B. So now remember that an interval notation is written from left to right. That if we keep going all the way to the left as far as we can, the farthest we can get is towards the negative infinity sign. And that continues on up until we get to A. Once we get to A is not being included, so we need a parentheses. And now there's a gap. This gap can be represented by U, and this stands for union. And that's used whenever you have any breaks or gaps. But now we're going to continue on to what our interval follows by. And it continues with B. Since B is included, we're going to have a bracket around B, and it's going to keep going on and on and on up until infinity, which we include with parentheses. And the reason why that is because we're never going to be able to reach infinity. So if we can't reach it, then that means that we can never include it. So since it's not being included, it has to have a parentheses. The intervals where your values are between A and B are actually called conjunctions. And the interval where your values are going opposite ways are called disjunctions. So now let's go ahead and talk about how to solve absolute value inequalities. And one thing you have to remember is that an inequality sign flips whenever it's multiplied or divided by a negative number. So let's try out the first example. Just like in the previous video, we have to set up two cases to solve for x because of the absolute value symbol. So remember that whenever you're solving for the absolute value, you have to start by writing what's inside of the absolute value. In this case, we have 3x minus 5, and our original case, we originally had the inequality be greater than or equal to 11. So this is our original case. And for the negative case, again, we're going to write what's inside. So we have 3x minus 5. But since it's a negative case, we have to change it to a negative 11. And here's where the inequality comes in. Because we have now changed the component of 11 to be negative, we also have to flip the inequality symbol. So if it was greater than or equal to, now it has to be less than or equal to. And this is the main key to point out. So now let's solve this just like a regular equation. So we can add 5 to both sides. And when we do that, we're left with 3x is greater than or equal to, we always carry down the inequality symbol. 11 plus 5, that's 16. And we can divide 3 to both sides to get the x by itself. So the 3's cancel out, and we're left that x is greater than or equal to 16 over 3. That's our first solution. Now we have to move on to the second one. For the second one, we can add again 5 to both sides. So if we add 5 to both sides, we get that 3x is less than or equal to, in this case, and negative 11 plus 5, that is negative 6. So if we divide 3 to both sides, we are left with x is less than or equal to negative 2. And now just be careful here, because even though we have the negative 6, the sign does not flip. It stays the same. And that is because we are not dividing by a negative number. The number that we are dividing by is 3, and 3 is positive. So our inequality symbol stays the same. Now let's see what the graph looks like. So because we have a negative 2 is before the 0. So we can write that all the way on the left-hand side. And 16 over 3, that's greater than a negative number because it's positive. So that can go on the right-hand side. And now let's actually graph it. Since 16 over 3 is greater than or equal to, it is being included. So we can fill that in. And anything greater than that is to the right. For x less than or equal to 2, since it's less than or equal to, we can fill that circle in. And anything less than that is anything to the left. So now let's try to write this in interval notation. So remember that we're reading it from left to right. The thing that is all the way to the left is negative infinity. So we're going to start off with negative infinity, and it is not included because we can't reach it. And it's going to continue on up until negative 2. And since it is included, we have little brackets. And since there is a gap, we need a union sign. And it continues on from 16. So we're going to have 16 over 3. And we include a bracket because it's being included. And that continues all up until infinity. And we close our parentheses. If it would have been a negative 3, we would have had to change this inequality sign. But for now, we leave it alone. So this is our final solution. And this is actually called interval notation. So let's try out the next one. Again, we have to write out the inside, so 12 minus 5x, and the original is less than or equal to 1. And for the other case, we have 12 minus 5x, and in this case, we have to flip the inequality because remember, now we're going to make this a negative 1. If we solve for this, we can subtract 12 to both sides, so we can subtract 12, and now we're left with negative 5x less than or equal to negative 11. So to solve for x, we have to divide both sides by negative 5. And if we do this, remember that our sign changes whenever we're dividing by a negative. This means that our greater than, our less than or equal to sign is going to change to greater than or equal to. And again, a negative over a negative, that is a positive, so we have 11 over 5, positive 11 over 5. So that's one solution. Now let's look at the other side. On the other side, we're going to perform exactly the same steps. So we're going to subtract 12 to both sides. And so we have negative 5x is greater than or equal to negative 1 minus 12 is negative 13. And again, we have to divide 5 to both sides. So now we have that x is, so again, we're dividing by a negative 5. So that means that we have to flip our inequality. So this is going to turn into less than or equal to. And a negative over a negative is positive, so this is going to be 13 over 5. And this is our other solution. So now let's write these in interval notation. But first, let's graph them to get an idea. Since we have the fractions 11 over 5 divided by 13 over 5, we know that 11 over 5 is smaller than 13 over 5. So that has to come first, and then we can place the 13 over 5, because the number line works from least to greatest. And now let's actually fill in the circles. So since we have that x is greater than or equal to 11 over 5, we know that 11 over 5 has to be filled in. And it is greater than, so that means that it is going to the right. And since we have that x is less than or equal to 13 over 5, 13 over 5 is also being included because it is less than or equal to. And that is going to the left. So the area that's being filled in is this middle section here. If we write this in interval notation, we're reading the graph from left to right. So the graph starts at 11 over 5, and we have to put a bracket because 11 over 5 is being included. And that is continuing on until 13 over 5, and that is also being included. So this is our solution set for this example. I want you guys to observe these next two problems. If we look at the absolute value of x plus 7 less than or equal to negative 3, you guys can pause the video and think about, is this possible? Is it possible for an absolute value to be less than or equal to a negative number? Think about the definition of the absolute value. Ready for the answer? The answer is, it is not possible for any absolute value to be less than any negative number. And that is because the absolute value makes everything positive. So if it can't be possible, then that means that this has no solution. Now take a moment and think about whether or not the absolute value can be greater than or equal to a negative number. In this playlist, I haven't talked about graph function transformations. So I'm going to use a line graph just to give you guys a visualization of what this kind of means. So we know that the absolute value makes everything positive. What that means is that you're going to have all of your values be greater than 0. All of them are going to be positive. And if all of them are going to be positive, negative 3 is way out here, way before the 0. So if all your values are positive, that means that all of your values are greater than or equal to negative 3. This means that your answer is all real numbers because all of them work. Another way to express this is that x is in the real numbers. This is a shorthand, and you can use it too. So this concludes our talk about absolute value. I hope that was helpful. Remember to subscribe and give this video a like.